Welcome. I'm super happy today to have Thor, Steen, Larsen present MLflow and Databricks experiment tracking and deployment. You're an MLflow ambassador and an ML engineer at DSB, Danish Railways. You had a very popular presentation and highly acclaimed presentation on the Databricks World Tour in Stockholm in December. So I'm super excited to hear this presentation. And yeah, please go ahead.
So today I'm going to talk about how you can in MLflow do experiment tracking, evaluation, and deployment, and what this is. Yeah, before I start, as I said, machine learning engineer at DSB, which is the national Danish train operator, and I have a background as a data scientist and IT engineer, and been an MLflow ambassador for almost a year now, which is kind of like, you can call it like kind of like a super fan of MLflow. They sent me like new clothes because I'm MLflow is a Python SDK or an API, as you can say, which uses a backend that comprises of a registry and a tracking server, but it can actually in the more I don't know if you can call it enterprise or what you want to call it, kind of setup, but it can also just be your local files. Actually, it's just like different kinds of ways to set it up and use it. You can just pip install MLflow, just start using the tracking APIs and so on, or you can spin up on different platforms. You can spin up a tracking server with some cloud storage and database. So the cloud storage is where you want to have all your artifacts, of course, in a central location, so you can work with your colleagues. And the database and cloud storage, that's also where you have like the metrics of your models and experiments. And it's a quite developed platform, open source wise, and of course it's also on Databricks. So it's, I guess it's like the most developed version of MLflow. It should actually be very similar, but this is of course what you get very ready version when you just roll out Databricks. It's like very core to what they do and maintained by them continuously. So yeah, different ways to set it up, going a bit into how to use it. So like, and why you want to use it. So I don't know how many data scientists are here or people, ML engineers, AI engineers who have been training their own models. If you have been doing that, you might recognize these kind of files, right? But I think anyone who's been working with Python knows that like a .bin file, it can be a lot of stuff. From my own experience, right? Like, well, you find something like this, like on your computer or maybe in the cloud, and you're like, what is this? It's like, is it some file? Oh yeah, it's the AI model width version. Is it of the model? Is it the production model? Yeah, it's like, is it the model I trained on where there was like a flaw in the data? I can really remember, right? And is it deployed? Like, you maybe also want to have like the full trace to where it's deployed. I can't remember if you deployed this model or have another model deployed. Like, you could go on, right? So what you want something like this with MLflow. This is what it looks like when you registered a model and you have an experiment run. So you can see here in the lower right, you can see I have like Databricks people will know these kind of like paths, right? You have the catalog, you have the schema, then you have the model name. Then you also have a version number. See, okay, this is exactly my model. And you can go into the artifacts, you can see the MLflow run ID. So this is really nice. And how do you get this? So everything starts with starting an experiment and starting MLflow run. In this MLflow run, you can do whatever you want. And of course, you want to log something to it, right? So if you're training a model, you want to log like the params, if you're testing in this run, training in this run, you want to log some metrics, right? And of course, you want to log the model in this run, you can also log the dataset you used and a lot of stuff there, like also auto logging features. So you don't need these like manual commands. There's a lot of stuff for like GenAI with the auto logging, so it can do the automatic tracing. Talk a little bit about that later. This is what creates like the nice page I just showed you before, right? And what if you just have the normal MLflow open source version, like when you go in to the MLflow UI, you can see like the MLflow run with all this stuff you logged. That's really good because you always have the trace, right? You always have the MLflow run ID, which tracks where you ran it and hopefully how you ran it if you logged the things. You can also track system metrics. So that's really nice if you have like a long run of something. Like, for example, if you're training on your GPU, you can see here that you're actually using the GPU, how much is getting used and so on. So logging a MLflow model is a little more work. There are some flavors. So for example, if you're using sklearn, it should be pretty straightforward. If you're using transformers, maybe a little bit harder, but also very nice if you have like a Hugging Face kind of pipeline. PyTorch needs a little more work. Like there's some different flavors, but what you always can do is that you can use the Python for the Python model, which is a class where you have at least a predict function where you take some input, you have some context. For example, you can use the context to log the model and then you return a prediction. And the prediction needs to fill some kind of like tensor schema. There are also some chat model you can use. You can also just have like a predict for a method which you can log. So there's like different kinds of options. When you log the model, you really want to make sure you have all the artifacts and you have all the requirements. So for example, if you're using Databricks, it will just take down what's going on. I think it will also do that in the open source. So what there is in your Python environment, but you might want to steer it a little bit. So you can use this like extra pip requirements to make sure you get everything in there. So what we really want to do is like when you're the same way as when you're building a Docker container, right? You want to kind of like containerize all your stuff, have all the artifacts, and I guess you don't want that in Docker container, I guess, but you will also you will have all your artifacts, like you will have the model.bin and so on. I will come more into this a little bit later, but it's like pretty crucial for like people fine-tuning models. You have to work a little bit with this and you have to learn how you make this predict and make sure you're returning the right stuff so everything works. There's also a requirement about signatures, which is, I think they said they want to enforce it for real. So yeah, be nice and have a signature. I think that's also something that's very important because often when you find a model, maybe it's registered in your catalog somewhere or your registry, I guess quite like with every API, you'll begin to think about like, how is this document? How do I call it? How do I call the model with the right input? What do I actually get back, right? And that's what you can be very nice to your colleagues and yourself, future self, is that you can kind of like define the signature, or you can say the schema of what the input should be and what the output will be. You can also put like an input example. So that's very nice. You need to, of course, still adhere to like the protocol, inference protocols. You can't input, output anything when you're logging and making signature models. That's something, you need to follow, but most tensors can't be logged. Like everything that can kind of be translated into a tensor can be used in a signature and in the input output. There are some different ways to evaluate models, right? This is like very specific. If you have a machine learning model, I would say like more like custom fine-tuned model. or like something you made up yourself. After training, you of course want to evaluate that. So often what you will do is you'll start a new run. You can also have it in the same run as you're training, right? But you might need evaluation later on, right? Continuously. So what you do is that if you have something that fits in this like kind of binary classification models, normal regression models, there are some built-in stuff, but often you will actually also write your own metrics. That's also something we've been doing. So when you do that, you can kind of like do structured evaluation, and you can log the metrics, whatever metrics you have. But yeah, you can also use the out of the box, and then you can also use thresholds if you want to log if it passed the threshold or not, as you can see here. So you can log the data set you used, and you will of course log the results of the evaluation. That's very nice, because then you can put that together with your logged model, so you can find the eval results easier, and then getting this kind of like model lineage is very nice. In the GenAI world, people may know that what you can do it the way I just showed you, where you write some metrics and some Python code and make it work. But often people use techniques like model as a judge. There's a lot of development in UI for this. So in here you can go in and see like traces. In the MLflow UI, you can go in and see like what prompts are there, what evaluations are there, and also the data sets. I think in Databricks you actually have the choice when you're inside MLflow to either use like the classic MLflow UI, where it's like for ML models, where you have all the models, and you can also use the GenAI UI, where you have the prompts, you have traces and everything. So it's actually two kind of like views in the MLflow. One thing that's kind of out of the box is model as a judge. So using some model, you can evaluate your prompt, how it went. So if you make a prompt, you give it to some model, your own model or foundation model, you get a response. You can use the kind of like a model in the middle to kind of see, using, for example, here, I think it's like, is the answer in English, right? You can say that, okay, I'm gonna use another LLM to kind of like judge, is that correct? And then it will do that and give you feedback if it's like, if it was passed. And just like a lot of options to do this. They also, I'm not too familiar with that, but there are also options to do it with agents, with different agent frameworks. I've been using it also myself with LangChain. It helps a lot with the development of your prompts, the evaluations, because I think it's that's something that can be very, can be a little more like loose when people do prompts. And think MLflow is doing a lot to kind of like help people be more structured about like how they evaluate prompts and trace what the LLM said and did, and what foundation model you used, how many tokens you used. This is also something you can see in this UI. And you can also implement this in the tracing, where you can see what the prompt was and what the LLM outputted. You can also put that inside your applications, so you can get like tracing if people are running your agent or RAG application or whatever you're running. I think it's a lot of options here. Yeah, but a fair warning, I guess, as you said, I'm more like an ML engineer, so my experience is a lot with like fine-tuning computer vision models and classification models and this kind of stuff. So I'm often in the normal MLflow UI and writing my own metrics and logging my own custom Python models. But there is, of course, also this. I also work with this using an LLM, using a prompt, versioning your prompt, this kind of stuff. I want to close off a bit with the deployment of models using MLflow. Open source way is like you kind of like build a Docker container and then you deploy it. Everybody knows Docker, right? Then you can deploy it on different platforms. They have some help with that in the MLflow libraries. Yeah, so you can actually just write MLflow model serve, and then it will spin some local Flash server up. Often, of course, you'll have another Docker container that's maybe a little more production ready. You can either do this like using on Kubernetes. You can use, for example, kserve using the MLflow framework, where it will spin up what they call, in case of, I think they call it an inference service, which is kind of like a production-ready server you can just use in your Kubernetes clusters, following to the same inference protocol as I talked about earlier. In Databricks, of course, even easier. You just click deploy model, if you registered your model and logged your model correctly, it will just deploy it using CPU, GPU, whatever you're doing. And yeah, different platforms, many choices here. What we have been very happy about is also the asset bundles. So using some GitOps, you can put everything down, your Databricks jobs, your training jobs using MLflow tracking API, and can also own the different resources using your service principal and so on. That way you can kind of get this very nice separation using GitOps of your different environments, using the same code base. So what you often will have is that you have the staging environment where you just test your code, right? You test your job code. So you'll just start testing out your code in the staging environment. Maybe you'll have some test data in there. And then you will go to the prod environment where you have the real data, and that's where you will do the training, right, of the model. Often you'll have like in the old MLflow, you will have this like, I have a staging model or a production model, or I have a non-stage model. And that's kind of like a legacy thing. In MLflow now, we're using aliases. So you could, for example, have an alias that's like staging model, prod model. Of course, you have the version number of your MLflow model, but that's kind of like how you really keep track of your model, right? Because then you can reference that alias. You can also do this with prompts. Then you can reference that back and not thinking too much about the version. So for example, I have my best model that's deployed. I have that with a prod alias, and then I can reference that back. Because of course there's some models which will go into training and not be the best, and they will be like maybe not something you want to put the prod alias on, right? Maybe we'll have different kinds of the same model, registered that's the same model. So the aliases are very useful as a reference, together with, of course, the catalog schema model name. In our own use case, we've been using the Databricks API also to kind of like serve the models on Databricks. I think there's also some out-of-the-box functionality that we didn't know too much about, but what we actually ended up with is that like we had for one of our production models, we had like a job that called Databricks APIs inside Databricks, running inside the Databricks already, right? And then would also been running outside if you had authentication, of course. And then that's kind of like what deploys in the model serving platform. Just a quick note about, again, like what's inside the MLflow model. So like if you want the model serving to work, you want to have logged everything, right? You know, in an MLflow model, like in any kind of server, you have like some binary files, have some code, libraries, with data. Then you also have the signatures and so on. So you need like everything of this like to be working very well. And that's also what they kind of like try to help with the flavors in the MLflow, that you have everything ready following the inference protocol to be able to just serve the model. And what's really nice is also you can always try to test this by just, when you log your model, you can try to load it again using the model URI, which the model URI, for example, it could be, again, the catalog I'm using, the schema I'm using, the model name I'm using, then an alias, for example, prod, then I will load that, or like staging, and then I will load that model into whatever script I'm doing. Then I can always just call model.predict, and then I'll get the functionality, which is also going to be how the MLflow model is going to work like when you call it, for example, with an API. can also deploy models to like the live table jobs and so on. Yeah, you can easily test if it works because it's gonna in Python because it's gonna work more or less the same when you do the API, and that's why you have this inference protocol, right? So you can ensure that input output is more or less the same in the server and whatever you're using. When a Python model is loaded, it's loading the context, loading the artifacts, and when you're calling to predict, you're calling this, kind of like simple method where you are calling your model and returning something that's some kind of tensor. Like there are a lot of features coming all the time to MLflow. They're developing a lot for like everybody else. They're developing a lot of stuff for like GenAI and LLMs. So keep an eye on that. I have myself been using the algorithmic optimization for prompts. That's really cool. You can also use that in Nordic languages at least. So you should check that out if you're doing prompt engineering. And of course, I'm also gonna make a commercial for the blog because I have a blog post, a blog where you can read a bit more about like how you can track datasets with images, but also just in general, like image models and also datasets, how to log them in MLflow, because there are some caveats to that. Some discussion actually is quite interesting on how you want to do it. Of course, if it's the Databricks people here today, they want to have like managed table with their stuff in that one, I assume, right? But for datasets with images, it can actually be a little bit more tricky. Because you can also just put that into a data table on Databricks. It can be a bit cumbersome. So read that article if you want to hear more about that. The last thing I want to close off with is a little bit appendix. So now we're talking about images and computer vision models because I've been working a lot with that. So one thing you should know when you're doing like deployment with MLflow models is that everything is a tensor, as I said, and it has to be like that. There is, at this moment, as far as I know, no file support. I think streaming support is under development, but right now you have to adhere to this pretty strict protocol for tensors. That's of course not if you're using chat models or LLMs. That's a little bit different. But for like traditional ML models, right, you have to follow this protocol. Everything needs to be a tensor, and that's actually, as you might imagine, quite heavy. You don't really want to send these like big arrays of numbers back and forth. And we at least been seeing that it was like way too slow for us. What we did for our computer vision model was to kind of like use the MLflow experiment tracking to kind of like track the models, register the models, so we could keep a track of what was the best models, what was the best data, our metrics and so on. And we also been experimenting with deploying them. We've been using LLMs actually in productions and production deployments where we deployed that using MLflow model serving on Databricks. And now we're also using Kserve on our own Kubernetes clusters for MLflow model serving. Computer vision models do often not require the kind of like same level of GPU as LLMs do, right? Or VLMs. That's something a little bit tricky with Databricks, that you kind of like, as far as I know, in the instance we have in Sweden, you even need to choose like a T4 or an A100 for like your deployments. Like, of course, you could use a T4, but even a T4 is a lot of compute, at least for our computer vision models. So we actually chose not for the LLMs, we use it as that, but for the computer vision models, we actually don't use MLflow model serving. For one, because we want to limit the I/O time. You saw this with all the numbers going in and out, right? The API that's really slow. You can't really do real time on that, but also just not to waste compute, because GPUs very expensive, even though they're getting cheaper and cheaper. So what we ended up doing is that we just loaded into our workload. You can do that like using a Delta live table workload if you want to do streaming. In our case, we used a Kubernetes Docker build thing. So we just called Databricks MLflow API, loaded our model our custom Python model into the application, right? Then we got like, as I showed you, I had like to predict. So just call it predict. We know what's going in and out, right? That worked pretty well for us. I think that's it. And yeah, of course, check out the MLflow org for more information.